இருக்குன்னு பார்க்குறேன். கொடூரமான குணமாக இருக்கும். என்னங்க சார்? அடுத்து வரமாட்டாங்க. யூடியூப் ஸ்ட்ரீம் ஆகுது சார். ஷேர் பண்ணிட்டேன் உங்களுக்கு. நான் செக் பண்ணிக்கிறேன். நீங்கள் அப்படியே அவரை இது பண்ணிவிட்டு இதை ஆக்டிவேட் பண்ணிக்கிறேன். நான் செக் பண்ணிக்கிறேன். நீங்கள் நிறைய ஆக்டிவேட் பண்ணுங்க. இப்போ நீங்கள் வாங்க கோவிந்த் இருக்கீங்களா? இப்போ அட்மிட் பண்ணிட்டேன் சார் எல்லாருக்கும். எல்லாருக்கும் ஒரு 5 மினிட்ஸ் வந்து அட்மிட் பண்ணுங்க. ஆமாம், இப்போ எல்லாரும் அட்மிட் பண்ணிட்டாங்க. 50 பேர் வந்தாங்க. அது என்னென்ன சார், கூகுள் மீட் அதில் தான் பண்ண முடியும். இங்கே நெட்வொர்க் ப்ராப்ளம்னால யூடியூப் ஸ்ட்ரீமிங் கொஞ்சம் ஸ்லோவாக இருக்கும். அந்த ப்ராப்ளம் என்னன்னா ப்ரோக்ராம் சார் என்ன ரொம்பவும் பண்ண முடியல. அதனால கொஞ்ச நேரம் எனக்கு 5 மினிட்ஸ் போட்டுருக்கேன். ப்ரோக்ராம் யார் அட்டன் பண்ணாலும் அவங்க நிறைய விட்டுருவாங்க. எல்லாம் சவாலை வச்சு யாருமே பார்க்கறது அப்புறம் உள்ளதான் சொல்லிக்கலாம். அப்படிங்களா? சரி சார். அப்படியா? வரணும் சார். சார் காசு சரிங்க சார். நீங்கள் வாங்க வாங்க உள்ள வாங்க. வீட்டிலையும் போட்டுவிட்டேன். போடையும் போடுறது முதல் இதுக்கு தான் வரலாம்.
let us start பண்ணிடலாமா?
Yes sir, we start sir.
Okay. So first of all, that is Pandeyarajan. So he is the professor at the head of Agni College of Technology, Chennai. He has published many number of papers. That is he has published minimum 40 papers. So he is well versed in this welding area. So I hope this presentation will be helpful for all the participants. Thank you, Pandeyarajan.
Sir, thank you so much, sir.
Share your presentation.
Yes, sir. Sir, thank you so much for giving this opportunity, sir. Thank you so much, Dr. andAdditive, sir. Sir, very good evening all. My name is Dr. R. Pandeyarajan, Professor and Head of the Department of Mechatronics Engineering, Agni College of Technology, Chennai. Today our session topic is the exploratory study of friction stir welding in hybrid metal metals composite materials. The outline of today's session is Introduction, Experimental Methodology, microstructural and mechanical properties of metal matrix composite material, development of design matrix and the process of conducting friction stir welding experiments based on design of experiment plan, and the validation of optimized process parameter by using mechanical and metallurgical characterization of weldments, and finally conclusion of this session. The introduction of composite material. Recently, all automotive engineering sectors very demand for use the new and high performance material, but still the conventional material or non-metallic material or alloy materials are not satisfy the current engineering demand. So all the industries focus to find the new material or composite material. The composite materials only satisfy the current engineering demand for particular properties of the material, like mechanical properties of the composite material, like mechanical properties, tensile strength or hardness or wear resistance, better toughness and high strength. The application of aluminum based composite material. There are the few applications of aluminum based composite material. The gas turbine engine, particularly used in guide vans. The military aircraft using in fins and fuel access door covers. In helipad industries using rotating blade sleeves. The railways and the passenger cars utilizing fabricate the brake disc pads. And the automotive industries are using various parts, valves, air parts, engine blocks, pistons, cylinder lines, suspension arm, and driving subs. In electronic packaging industries also utilizing in the aluminum based composite material, particularly in microprocessor LEDs and integrated the heat sinks. In particular, boron based aluminum based composite material, particularly used in nuclear power plant in neutron absorption systems. This is the few application of aluminum based composite materials. The basic characterization of composite material is, compared to base metal alloy, the aluminum based compared to base metal alloy, the composite is produce the maximum strength of the material. The basic property is superior mechanical properties, tensile strength and hardness. The tribological properties of wear and coefficient of friction and warm surfaces analysis, grip resistant and corrosion behavior. This is the basic characterization of composites material. The major objective of composite material is, compared to base metal alloy, the main objective of metal matrix composite is to achieve the maximum or specific mechanical properties of the structural component. Naturally, the ceramic reinforcement particles are very hard and very stronger material. It is only decide the properties of the composite material. So the researcher focused the particular ceramic particulates on the composite material. The reinforcement particulates only decide the properties of the composite materials. There are the different kind of welding process utilizing in composite material. Particularly, there are the two types of welding process: the fusion and the non-fusion welding process mostly utilized there. The gas tungsten arc welding, gas metal arc welding, laser beam welding, electron beam welding, and non-fusion welding are friction welding and friction stir welding process. In 1991 to still 2023 onwards, there are the many researchers worked in fusion welding process, but many of the researchers concluded and reported that the fusion welding is not suitable in aluminum based composite materials because some problems during the fusion welding process. Particularly, there are the two problems occur in aluminum based composite material during the welding process. The first problem is the problem associated with aluminum matrix materials. Second problem is the problem associated with inclusion of hard ceramic particulates in aluminum based composite material. The first problem is aluminum matrix problem is high thermal expansion, high thermal conductivity, solidification shrinkages, incomplete mixing of parent and filler materials, coarse grain structure of weld zones, and the presence of oxides in situ. This is the major problem associated in aluminum matrix materials. And the second problem is the reinforcement of hard ceramic particulates in problem. There are the two major problems: mismatch of coefficient in thermal expansions and the chemical reaction of the
எத்தனை பண்ணாலும் அதுக்கு ஒரு சொல்யூஷன் எடுத்து வச்சிருக்கிறேன். நானும் லிட்டரேச்சர் சொல்லி ஏகப்பட்ட எடுத்து பார்த்துட்டேன். எல்லா இதுவும் வந்து ஒரு சொல்யூஷன் எடுத்து வச்சிருக்கிறாங்க. நம்ம புதுசா ஒரு டிசைன் கிரியேட் பண்ணாதான் அது முடிய மாட்டேங்குது. அப்படி
this is the basic function of friction stir welding process. The friction stir welding process is a non-solid state welding process. It is induced by Welding Institute in 1991, Thomson at 1991. This is the basic working principle diagram of friction stir welding process. There are the 4 steps followed by friction stir welding process. The first step one is a joining of tool and working material. Insert the tool joining and pull of it from the tool. This is the basic function of friction stir welding process. The major advantages of friction stir welding process is
ஒர்க் பண்ண சார் அந்த இதுக்கு அதில் ஏதாவது அடிஷன் பண்ணி அதோட ப்ராப்பர்ட்டி இம்ப்ரூவ் பண்ண முடியுமான்னு பார்க்கணும். ஆக்சுவலி சார் நான் வந்து நானும் தெரிஞ்சுக்கிறேன்.
No requirement of edge preparations and no requirement of filler materials, no requirement of stringages. There are the many advantages in friction stir welding process. Particularly, the friction stir welding process application mostly utilized in aerospace industries. This is the sample images of aerospace engineering used in friction stir welding process. The good quality of friction stir welding process is done by, there are the 2 major parameters affecting the good welded qualities. One is a machining parameters. The machining parameters are tool rotational velocity, welding speed, tilting angle, and plunge depth. This is the major machining parameters to affect the weld quality. Next major influencing parameter is tool parameter. The tool parameters are solder diameter, solder topology, and pin diameter and pin topology. And finally, the pin length. This is the major influencing parameters of friction stir welding process parameter. There are the many methods to find the optimized the friction stir welding process parameter, which are the most influenced parameter to find the optimum solution by using. There are the many techniques available in recent days: the Takeuchi method, gray relation analysis, partial swarm analysis, and response surface methodology. Compared to other methodologies, the RSM methodology is mostly easy to find the optimum solution of to influencing the input parameters of the friction stir welding process. The RSM parameters, maximum utilizing the disability approaches, is used to identify the optimum welding process parameter to maximize the mechanical properties and to predict the optimum welding process parameters accurately without consuming time, materials, and labor. About various methods available, and one of the such method is RSM methodology. The RSM methodology maximum utilization design experiment software. There are the various types of version software utilized in recent days. Version 8 to version 10 is available. The goals are objective for responses are expressed in terms of optimized in represented by numerical and graphical representations. The relationship among actual and predicted values are and percentage error value also calculated by the output responses of tensile strength and hardness is derived by the DOE experiments respectively. The actual values is pure experimental results. The predicted value means once we have to develop the DOE, find the number of experiments, the number of experiments done by using experimental method, and find the mechanical characterization, tensile strength and hardness values are input to the DOE, directly find with mathematical equation. Once the session is over, I will display with the design of experiment software how to we will use. I will demonstrate at the end of the session. Once we develop the mathematical equations, the contour plot is used to define the supervising or overlaying the critical responses of the visual search becomes the possibles. Once we find the optimum solution on the friction stir welded process parameter, once again we have to test it with experimental result, validation test result. The validation result is very important. Once again, 3 to 5 trials we make another one time, compare with experimental and predicted values, and also we have to find with percentage of error. The percentage of error is less than 5% means definitely we have to use with the optimum process parameter. It is produced with the good quality of welded joints. This is the overall experimental methodology followed by the metal matrix composite using friction stir welding process parameter. The first step one is material selection. The composite means the material selection is very important in researches. The composite material, there are the two materials. One is a matrix material, another one is a reinforcement particle. The matrix material is particularly choose with your application point of view. You will choose. For example, this session I will take with AA6061 is a wrought alloy, is a basic alloy. We have to use with this matrix material, and we have to use with reinforcement particulate. This session I will use, there are the two types of reinforcement particulate. One of the particulate, primary reinforcement particulate is ZRO2, is a primary reinforcement particulate, and secondary reinforcement particulate is graphite. This is the material selection. Second is a fabrication of metal matrix composite material. There are the different types of fabrication methods available in metal matrix composite material, but this session we focus with the stir casting method because this method is available in many engineering colleges in Tamil Nadu, so we have to use with stir casting method. And once we have to fabricate the metal matrix composite material, and we have to find the characterization of metal matrix composite material in different weight percentage of composite material. Once we calculate the characterization of the metal matrix composite material, we select the suitable weight percentage of matrix and reinforcement particulates in composite material. Once finalize the composite material, we do the welding process. We do the experiment of friction stir welding process under the principle of design of experiment plan. Once we have to develop the DOE, the number of trials is predicted. The number of trial is predicted. After then we go to experimental analysis by using friction stir welding process with mechanical characterizations also. Once done the mechanical and properties, we input to the optimization technique, find the optimized process parameter, and also we have to find the mechanical and metallurgical characterization of the welded joint. This is the overall flow of friction stir welding of aluminum based composite materials. This is the example, the selection of matrix material. This session I will consider only on AA6061 alloy, is a basic wrought alloy AA6061 alloy is a selected matrix based on better thermal conductivity, low density, and easy processing, and better castability and weldability of the material. Once we have to buy the AA6061 alloy, definitely we have to find the how many percentage of each composition in material: silicon, ferrous, copper, magnesium. You find the spectrometer analysis, find the composition, and confirm the wrought alloy AA6061. And the selection of reinforcement particles, this is the most important session in reinforcement, choosing of reinforcement particulate. This session I will consider two types of reinforcement particulate: ZrO2, zirconium dioxide, and graphite. ZrO2, zirconium dioxide, is most responses in case multi-industrial and technological application in recent material studies. This is due to the immense mechanical properties and low thermal expansion and less cost and thermal conductivity also. The ZrO2 only used to improve the mechanical properties of the composite material, and we have to also utilize the graphite. Graphite is a secondary reinforcement particulate. It is used to improve the tribological behavior of the composite material. Once the researcher is buying the both material, matrix material, and the reinforcement particulate, we definitely check with purity and particle size of the matrix and the reinforcement particulate. There are the many types of purity available in market. We need a research point of view more than 90% of purity and less than micron size also. Definitely measure that. After then we have to fabricate the metal matrix composite material by using stir casting method. This is the sample experimental image of stir casting method. The furnace is maintained minimum 1000 degrees Celsius to 1500 degrees Celsius. Based on matrix material, we have to set with the temperature, and the stir speed is minimum 350 to 450 RPM within 5 to 10 minutes minimum maintained. And compulsory, the reinforcement particulates are preheated to 350 degrees Celsius to 500 degrees Celsius, because to remove the moisture content of the reinforcement particulate. Suppose you have to not preheat the reinforcement particulate, there are the many defects production with metal matrix composite material. So definitely you have to preheat the reinforcement particulate. After then to mix the matrix material and to fabricate the homogeneous distribution of matrix and reinforcement particulate in aluminum based composite material. This is the example diagram of metal matrix composite material with various dimensions, casted piece, and different weight percentage of matrix and reinforcement particulate. The first, for example, first one experiment number 1 to experiment 6, this is a composite material for adding only ZrO2 material. And 7th experiment to 11th experiment, we conduct the hybrid metal matrix composite material. We add with both reinforcement particulate in ZrO2 and graphite. Once fabricate the composite material, we find the mechanical and metallurgical behavior of composite material. The first, the characterization of metal matrix composite material, the first image shows the only adding an ZrO2 particulate. For example, 0% of aluminum base alloy to produce the 30 HRC harness, and adding 2 to 10%, the harness value will be improved. This is first image to represent only adding an ZrO2 particulate in composite material. And second and third, the contour plot shows the influence of both reinforcement particulate. The x-axis shows the primary reinforcement particulate ZrO2 weight percentage, and the y-axis shows the graphite weight percentage particulate. Definitely, suppose there are hybrid metal matrix material means compulsory the researcher to display the 3D contour plot and 2D contour plot. This contour plot is easy to identify the which the reinforcement is mostly affected in output responses. For example, tensile strength or hardness or whatever it is, any properties. For example, the contour plot, the x-axis 6% of ZrO2 and minimum 2% of graphite is produced highest hardness value. Suppose example 2.5 ZrO2 and 6% of graphite, it is produced minimum level of hardness value. It is clearly to understand the which reinforcement is mostly affected the hardness properties of the composite material. Similarly, the tensile strength analysis of composite material, the x-axis shows the ZrO2 particle. The first image shows the only adding an ZrO2 particulate in metal matrix composite material, and the second and third image shows the hybrid metal matrix composite material. Previously we discussed the same thing. The x-axis shows the ZrO2 particulate and y-axis shows the graphite weight percentage. Z-axis shows the tensile strength value of metal matrix composite material. We have this graph 2D and 3D plot is clearly shows the which reinforcement is mostly affected the metal matrix composite material. The researchers do one thing. You add with only one reinforcement particulate means the bar chart or pie chart is very enough. There is no issues. Suppose you will fabricate the hybrid metal matrix composite means you have to show with 3D and 2D contour plot means definitely your paper is accepted in highest ranges of SCI and Q1 and Q2 journals. Do the research work and the best paper will be accepted in many reputed journals. And this is the basic and fundamental metallurgical behavior of metal matrix composite material. The image shows the XRD pattern of only adding an ZrO2 particulate. This is the example diagram. Okay, next image shows the hybrid composite material adding an ZrO2 and graphite particulate. Both XRD values are compared with the standard value in JCPDA data. The JCPDA data is very important. Is a standard data. Is a XRD pattern means definitely show with peak. How many peak values, how many percentage will be occur in composite material? You definitely the standard data is there in JCPDA data. You compare with your result, definitely the result will be okay. Suppose if any error occur in polishing method or roughing method, to reflect this JCPDA data, we will modify the result and take again the test results. This is the microstructural analysis of both hybrid and only adding an ZrO2 composite materials. This is the sample image of microstructural analysis. The arrow mark display the reinforcement particulates in composite materials. Similarly, this is the only magnification difference. This is our previous images shows the OM analysis, optical microscope analysis, and the next image is a SEM analysis. It's the same. Suppose you will check with micron size or you will check with grain size. Easy to calculation is there. The circle is there now. You will calculate the size. Some formula is there. The formula to apply. They find the number of grains in particular size. This is the basic and the fundamental process of friction stir welding process. The first image is a principal diagram of friction stir welding process, and the next is a experimental machine of friction stir welding. Suppose all the colleges available in vertical milling machines. The vertical milling machines also you have to change with some adapter. You have to use with friction stir welding machines also. There are the different types of tool used in friction stir welding process. The tool material is high carbon and high chromium steel was used to make the weld tool, which is the high carbon and high chromium D2 steels. In 2010, Dr. Murugan sir is reported that compared to many other tools, the square pin tool is produced the maximized the tensile strength and weld quality is high. And the Ashok Kumar SRM Madurai campus 2019 and 20 is published one paper and also reported and conclude the one session in tool parameter optimizations. The threaded and square pin tools only produce the maximized tensile strength. So this session we have to consider square pin tool is utilized in friction stir welding process parameters. The friction stir process parameter optimization in steel casting of aluminum based composite material. The box Pinjagan experimental design, there are the 3 factors and 3 levels was used to minimizing the number of experiments. By correlating the significant welding process parameter by using linear regression equations were developed to determine the ultimate tensile strength and hardness of friction stir welded composite using statistical design expert softwares. The optimization techniques and box Pinjagan method to find the optimum solution by using disability approaches was used to optimize the friction stir welding process parameter for simulation improvement of tensile strength and hardness weld composites. The optimum result obtained from the disability analysis. This is the systematic approach followed by the to find the optimum solution of friction stir welded aluminum based composite material. The step number 1 is material development. Material development means we have to fabricate the composite material and we have to choose with, we have to prefer with work holding device for 100 mm length and 50 mm width and thickness is 6 mm. Material preparation by using wire cut area machine. This is the material development process is step number 1. Step number 2 is material processing. We have to identify the friction stir welding process parameters. There are the many parameters affecting the weld quality. So the researchers focused with which parameter is mostly affected the parameter. We have to choose with 3 level or 4 level or 5 level. You choose with your parameter. This session we have to consider with 3 level parameters: tool rotational speed, welding speed and axial load. There are the 3 level we have to consider. The step number 3 is process parameter correlations. Process parameter correlation we have to choose with box Pinjagan method. It is used to develop the design matrix using 70 number of trials. After we have to develop with a design matrix to fabricate the weld joints and testing and the characterizations also done. The testing and alteration values also input to the box Pinjagan method to develop the linear equation by using ANOVA, analysis of variation, and develop the mathematical equation and find the error percentage of the mathematical equations. Finally, the step number 4, we have to find the optimum and the validation results. The optimum process parameters once we have to find with and evaluate the results from validation methods. Again, we have tested with 3 to 5 times and find the error percentage. This is the systematic approaches followed by the friction stir welding process parameter identification of optimization technique. The development of design matrix by using box Pinjagan method. We have to use with 3 level and 3 factor. 3 level and 3 factor we have to utilize. Tool rotational speed, welding speed and axial force we have to consider the 3 level. In addition, the order is maximize the tensile strength. The optimal design parameters were determined to maximize the tensile strength on friction stir welded metal matrix composites. The optimum design parameters were determined by using disability approaches. The example, we have to choose with 3 level. The tool rotational speed minimum range is 600. The example we take it 600 rpm is the lower range and the maximum range is 1000 rpm. The welding travel speed is 45 mm per minute. The maximum speed is 55 mm per minute. The axial force is 4 kN and maximum is 6 kN. There is the 3 process parameter and 3 level. We have to consider the input process parameter in friction stir welding, and we have to use with box pinching method. We develop the design matrix in 17 number of trials. After we find the 17 number of trials, we take and we do the experimental process, friction stir welding process and characterization. Those values input from the box pinching design matrix, we develop the polynomial equation to the experimental data by using linear regression method. The model was based on quadratic pattern and the apply the analysis of variation ANOVA. The interaction time and significant responses were identified by using F statics approaches was applied in evaluating the significant parameter. This is the sample equations of output responses in tensile strength and hardness. Once we develop the mathematical equations for output responses in hardness and tensile strength, we check with actual and predicted value of output responses. The actual value means pure experimental results. Pure experimental is 100% accurate results. Predicted means we have to develop the mathematical equation, and this is the mathematical results. Both are error percentage is very less than. We take the mathematical equation. The mathematical equation is okay. The r squared value is reflected by the error percentage of the mathematical equation. More than 0.95 means the r squared value is, you take the optimum solution of the process parameter in linear regression equation. If less than 0.90 means you don't take the equation. We have to change with model and design matrix, and once again we have to done with mathematical equation. After then we have to use with linear regression models, and the error percentage is very less than. We have to plot with perforation plot. The perforation plot is clearly shows that we taken as 3 input process parameter for tool rotational speed, welding speed and axial load. There are the 3 parameters. Compared to other 2 parameters, the tool rotational speed is mostly suffer in hardness and tensile strength. So mostly influenced parameter is tool rotational speed. The tool rotational speed is carefully decided at. We have to produce the good quality of welded joints in aluminum based composite materials. The perforation plot is used to identify the influence of input parameters, and the contour plot for is easy to identify and easy to visualize the which parameter is produce the highest tensile strength. For example, the right side is shows the 2D contour plot and the left side is shows the 3D contour plot. The x-axis shows the tool rotational speed and the y-axis shows the welding travel speed. The x-axis 600 to 1000 we take minimum and maximum range. Y-axis we take the welding travel speed minimum is 45 to 50. The maximum tool rotational speed 850 to 900 and the travel speed is 50 to 55 is produce the maximum tensile strength. The graph is clearly to shows the which parameter is mostly produce the maximum strength of the welded joints. The similar next contour plot for another two parameter axial load as well as tool rotational speed for 2D and 3D contour plot. The plot always displayed with using design of experiment software we taken as per the mathematical equation we developed with contour plot. And this is another two correlation of two parameter axial load as well as welding travel speed. This is the tensile strength, and the next contour plot also shows the output responses. Another one response hardness values also we consider tensile strength and hardness. This is the basic property. This session basic property we taken as. There are the two parameter only this image is considered. One is a tool rotational speed, another one is a welding travel speed. The maximum tool rotational speed 1000 and 55 rpm only produce the maximum hardness of the welded joints. To improve 1050 also hardness will be improved. The hardness will be improved. No? The mechanical the ductile to brittle always move. So the hardness will be we consider only on tensile strength. After that we will consider the hardness value. This is the another two process parameter we plotted it. Axial load as well as tool rotational speed. The similar graph for axial load and welding travel speed. Those are the contour plot is shows the most of the influence parameter which parameter is produce the highest mechanical properties to be achieved. After then we have to set with disability approaches the input responses for tool rotational speed, welding and load. This is the input process parameter. We set with importance is 3 and we maintain with criticism is in range. The output responses for the tensile strength and hardness is the level maintained by maximize and 5. Importance will be maintained by using disability approaches. Once we set the input parameters for the disability approaches, we plot the overlay plot. The overlay plot is shows the optimum process parameter and the design optimum process parameter and the friction stir welding process parameter. Once we have to find the optimized process parameter, again we have to validate the results. Validate the result by using 3 experiment or 4 experiment, and we have to check with actual and predicted value and percentage of error. The percentage of error is less than 3 at 3 to 5 range means the validation is okay. Suppose we have to error percentage is more than 10, again we have to evaluate the mathematical correlation linear regression equation. Again we have to test with samples. Again we have to validate the results. And finally we have to check with metrological characterization of friction stir welded metal matrix composite material by using microstructural analysis and macrostructural analysis by using optical microscopy images. The images is clearly shows that A to D is a high heat input of microstructure by using friction stir welding process. The first image is shows the weld nugget interfaces, and the second image is shows the thermomechanically affected zones, and the third image is shows the weld nugget zone. Final and the fourth image is shows the base metal of composite material. This is the sample image of microstructure analysis in welded joints in optimized process parameters. And finally we calculate the hardness survey of each material. This is the every 0.1 mm we check with the hardness value. Compared to base metal alloy, the weld nugget, the center point, the hardness will be high. Based on matrix and base metal, may be changes in hardness value. This is the hardness survey of welded joint of aluminum based composite materials. This is the sample image. And finally conclusions. The experiments were carried out different level of composites by the proper mixing of base metal, which is reinforcement during stir casting, was visible with result obtaining from the optimal microstructural analysis. The metallurgical characterizations of XRD, OM, and spectrometer analysis and EDX and XRD is used to easy to do homogeneous distribution of metal matrix composite material, and primary reinforcement materials are only focus the particular mechanic to improve the particular properties of the composite material, and the secondary reinforcement materials are used to improve the tribological behavior of the composite material. Once we have to find with best weight percentage of aluminum based composite material, we do the friction stir welding process parameter, and we have to find the do the optimization technique and find the most influencing parameter, and also we have to use with metallurgical characterization of weldments by using OM analysis and different zones, and harness survey also done by the optimized process parameter. So, thank you. So, before this session, for example, dear participants, this is the design experiment software for version 13. Sir, just 1 minute, sir. Actually, I will show with some other design. You make it new design. Response surface methodology. We have to use with different methods available in RSM method, central composite design, and box Pinjagan method, or customized design also using. The box Pinjagan method means we set with factors 3 level or 4 level or 5 level. We set with tool rotational speed, minimum range, whatever it is, 600 to 1000, and welding speed is a very easiest method of to finding the optimized solution. The researchers do the use the RSM software 45 to 60 and the axial load 4 to 6. Sorry, I will put randomly. The responses means output responses means our tensile strength and hardness, whatever it is, three in a tribological also we have to find, we include the another one responses also. This is the design experiments for to find the number of trials by using design of experiments. Once we have to find with the design of experiment, we do the experimental results from tensile strength and hardness. We include the tensile strength and hardness value, and also we try with another, we include some other data, and easy to find the numerical and graphical representation of optimized solution of influencing, find the optimized solution of influenced parameters. This is the actually this is not hands-on section. If you need help, definitely you send the email. I will definitely help with the design experiments of the player participants. I thank you so much from Dr. A.N. Balaji sir giving these opportunities for this session. Thank you so much, sir.
Thank you, Pandirajan. Nice presentation.
Yes, thank you, sir.
Participants, any queries?
Sir, before ending of this session, I to give some small words from 2 minutes. 2 minutes, sir. Dear participants, actually 2000, sir, I am not, sorry, sir, 2 minutes, sir, please. Actually, in all the industries, for all participants, actually, direct 2000 2005ல இருந்து 2012 onwards all the industries moved to, இப்போ நீங்களும் ஒர்க் பண்ணியிருக்கலாம், நானும் ஒர்க் பண்ணியிருப்பேன், every participants, all the peoples are working with industries also. All the industries 2005 to 2010 work with only production point of view. Suppose இப்போ நீங்கள் ஃபஸ்ட்டு ஷிஃப்ட் வேலை பார்த்துருந்தீங்கன்னா நீங்கள் 180 பார்ட் வந்து ப்ரொடக்ஷன் பண்ணியிருந்தீங்கன்னா நெக்ஸ்ட் ஷிஃப்ட் போகிறப்ப நான் 180க்கு மேலே வந்து ப்ரொடக்ஷன் வந்து போட்டுருந்துருக்கணும். நெக்ஸ்ட் ஷிஃப்ட் வரவே 200 ரீச் பண்ணியிருக்கணும். லெஸ் தென் 150 போட்டிருந்தோம்னா யூ ஆர் அன்சூட்டபிள் பர்சன் ஃபார் டூ தி ஒர்க். ஸோ அப்போ ஹைக் எதுவுமே எதிர்பார்க்க முடியாது. ஸோ ஆல் த இண்டஸ்ட்ரீஸ் 2005 to 2010 onwards ஃபோக்கஸ் தி ப்ரொடக்ஷன் பாயிண்ட் ஆஃப் வியூவில் தான் ஒர்க் பண்ணிக்கிட்டே இருந்தாங்க. Later than 2010 to 2015 all the industries moved to quality point of viewல வந்து ஒர்க் பண்ண ஆரம்பிச்சாங்க. ஏன்னா அப்போ வந்து ஆக்சுவலி all the industries to import the CNC machines இம்போர்ட் பண்ண ஆரம்பிச்சாங்க. சிஎன்சி மிஷின்ஸ் கொண்டு வந்தாங்க, ஆட்டோமேஷன்ஸை இம்ப்ளிமெண்ட் பண்ணாங்க, ரொபோட்டிக்ஸை வந்து இம்ப்ளிமெண்ட் பண்ணாங்க. ஸோ ப்ரொடக்ஷன் பாயிண்ட் ஆஃப் வியூவில் தேர் இஸ் நோ இஷ்யூஸ் இன் இண்டஸ்ட்ரீஸ். ஸோ குவாலிட்டியும் வந்துச்சு. அது அஸ் வெல் அஸ் சேம் டைமில் வந்து பார்த்துட்டிங்கன்னா ப்ரொடக்ஷனும் அவங்களால ரீச் பண்ண முடிஞ்சிச்சு 2015 வரைக்கும். ஸோ இதுக்கு பெஸ்ட் எக்ஸாம்பிள் வந்து பார்த்துட்டிங்கன்னா டாட்டான்னு சொல்லலாம். டாட்டா கம்பெனிஸ் இஸ் ஃபர்ஸ்ட் வந்து பார்த்துட்டிங்கன்னா 1 lakh rupeesல வந்து நானோ காரை வந்து ப்ரொடக்ஷன் பண்ணி லான்ச் பண்ணுறேன்னு சொல்லியிருந்தாங்க. பட் ஆனால் அது வந்து நிறைய பீப்புள்ஸ் வந்து காஸ்ட் இஸ் வெரி லெஸ், வி ஆர் ஆல்சோ பை த சம் கார் ஆர்டர் பண்ணிடலாம்னு சொல்லிட்டு எல்லா பேருமே ஆர்டர் பண்ணியிருந்தாங்க. பட் 1 or 2 years later then we released the nano car. After then அவங்க வந்து குவாலிட்டி சரியில்லைன்னு சொல்லிட்டு அது ரீபக் தான் எடுத்தாங்க. கஸ்டமர்ஸ் ஆல்சோ நாட் சாட்டிஸ்ஃபைட் வித் தி ப்ராடக்ட். ஸோ அட் த டைமில் குவாலிட்டியை ஃபோக்கஸ் பண்ணி அந்த 2015 வரைக்கும் எல்லா இண்டஸ்ட்ரியும் மூவ் பண்ணாங்க. அதுக்கப்புறம் குவாலிட்டியை வந்து நல்லா ரீச் பண்ணி இப்போ எல்லா கம்பெனியுமே மோஸ்ட் ஆஃப் ஆல் அந்த அல்ட்ராஸ்லேருந்து டொயோட்டா இருக்கும் 5 star ரேட்டிங் 4 star ரேட்டிங் சொல்லிட்டு குவாலிட்டியை பேஸ் பண்ணியில் இப்போ வந்து இம்ப்ரூவ் பண்ணிட்டாங்க. பட் இப்போ வந்து பார்த்துட்டிங்கன்னா 2020 23 still now 25 onwards all the industries research focused by recycling, green energy and new material development. அதை வந்து ஃபோக்கஸ் பண்ணி இப்போ வந்து பொல்யூஷன் ரிலேட்டடாகவும் க்ரீன் எனர்ஜி ரிலேட்டடாகவும் எல்லா இண்டஸ்ட்ரியுமே ஒர்க் பண்ணுறாங்க. லாஸ்ட் வீக் ஐ மீட் வித் லியோ பெர்னால்டு சார். லியோ பெர்னால்டு இஸ் அசோக் லைலண்ட் பர்சன் ஃப்ரம் ப்ரொடக்ஷன் மேனேஜர் இன் எண்ணூர் பிளான்ட். இஸ் பர்சன் பர்சனலி மீட் பண்ணியிருந்தேன். அப்போ மீட் பண்ணுறப்ப இஸ் பர்சன் ஒன்லி ஃபார் டன் பை டிஎம்இ டிப்ளமோ ஹோல்டர், ஐடிஐ அண்ட் டிப்ளமோ ஹோல்டர். பட் இஸ் த பர்சன் டூயிங் தி ரிசர்ச் ஒர்க். அந்த பெயிண்ட் அடிக்கிறது அந்த சேசிஸ்ல இருந்து கார்ஸ் எல்லாத்துலேயுமே பெயிண்ட் அடிச்சு அந்த பெயிண்டை வந்து என்ன பண்ணுறாங்கன்னா அது பர் மந்த்துக்கு வந்து க்ரோஸ் கணக்கில் வந்து அசோக் லைலண்டுக்கு வந்து லாஸ் ஆகுது. பர் மந்த்துக்கு க்ரோஸ் கணக்கு அமௌண்ட்ஸ் வந்து வேஸ்டேஜ் ஆகுது. அதை லெஸ் பண்ணுறதுக்கு ஹீஸ் த பர்சன் இஸ் அ மேனேஜர், பிளான்ட் மேனேஜர், டூ தி சம் ரிசர்ச் ஒர்க் அண்ட் ரெடியூஸ் தி 0%. இப்போ வந்து 0% ஆக்கிட்டாரு. அந்த வேஸ்ட் ஆகுற அந்த பெயிண்டை வந்து கலெக்ட் பண்ணி அதை வந்து செகண்டரி பெயிண்டாக யூஸ் பண்ணி அதுக்கு பேட்டன்ட் வாங்கி இப்போ கிட்டத்தட்ட ஃபாரின்ஸ்லேயும் சரி இந்தியாஸ்லேயும் சரி ஏகப்பட்ட அவார்ட்ஸ் அண்ட் ரிவார்ட்ஸ் வந்து வாங்கியிருக்காங்க. அது வந்து இப்போ சாதாரண ஒரு M2 பண்ணுற டிஎம்இ டிப்ளமோ ஹோல்டர் அவர் ரிசர்ச் பண்ணி ஒரு நியூ மெட்டீரியல் கண்டுபிடிச்சிருக்காரு. அந்த நியூ மெட்டீரியலில் 2 பை ப்ராடக்ட்ஸை கண்டுபிடிச்சா அந்த பை ப்ராடக்டை அசோக் லைலண்டில் பை மெட்டீரியல்ஸில் பெயிண்டிங் வரைக்கும் யூஸ் பண்ணுறாங்க. டியர் பார்ட்டிசிபென்ட்ஸ், நம்ம ஆல் த பார்ட்டிசிபென்ட்ஸும் ரிசர்ச் பண்ணுறத கரெக்டாக ரிசர்ச் பண்ணி இது ஃபோக்கஸ்டாக போனோம்னா மேபி வி ஹாவ் டு யூஸ் வித் பை ப்ராடக்ட்ஸ் ஆல்சோ. சார் தேங்க்யூ ஸோ மச் சார், தேங்க்யூ ஸோ மச்.
Participants, any queries?
Sir, good evening, sir.
Sir, good evening, sir.
What is the research scope for frictional stir welding of hybrid metal matrix composite?
Sir?
Research scope. Still you have a lot of scope for hybrid metal matrix composite friction stir welding.
Yes sir, recently many researchers do with hybrid metal matrix composite material with using fusion and non-fusion welding also.
Hello.
Sir,
am I audible?
Yes sir, you are audible.
My question is audible.
Sir, if you have any queries now, your chat box is there. You will chat it. I to give answer, sir.
Okay, okay, sir. Thank you.
So is there is any queries?
Sir, thank you, sir.
Thank you very much.
Sir, thank you so much for giving this opportunity, sir.
Okay,
Thank you
okay.
so much.
Thank you, Pandey. Thank you, thank you.
Yes, sir. Sir, actually, participants, to give some information from you. There are the two. I will learn from Dr. A.N. Balaji, sir. He is the person. He is most experienced person in composite material. He is do the many researches in composite material. I learned from actually Balaji, sir. And I learned from welding பத்தி நான் தெரிஞ்சுக்கிட்டேன்னா I think Dr. R. Ashok Kumar sir in our department head in SRM Madurai campus. I learned from both of them and I
Thank
do
you.
the research work and I will thank you so much from both of you, sir. Thank you so much.
Thank you, Pa. Thank you, Pa.
Thank you, sir. Thank you so much, sir.
You can leave, Pa.
Yes, sir. Thank you, sir.
The participants' feedback link is available in the chat box. Please fill the feedbacks. And it's also available in the YouTube link also. Okay. First session is already feedback is already closed. Okay. So let us continue. Join the next session itself. Sir. Okay. Thank you. Thank you very much.